It's interesting, this idea of the Big Bang created the universe. That's what Einstein's theory says. That's textbook cosmology, if you like. But the current textbook picture is there was a phase in the universe's life before the Big Bang, if you define the Big Bang as the hot, dense phase from which the universe appeared to sort of burst forth 13.8 billion years ago. And that phase is called inflation. So what we think happened is that before that, the universe was accelerating exponentially fast. It means it was doubling and doubling and doubling in size. And the numbers are ridiculous. We think that if you started with a universe that was smaller than a single atom, then it would be bigger by a long way than the whole observable universe, 350 billion galaxies in it, in less than a millionths of a second.
Was the Big Bang the start of the universe, or did something exist before it? Brian Cox is a well-known physicist in the English-speaking world. He explains the universe's structure and meaning in a straightforward way. Brian Cox has now shared his perspective on what existed before the Big Bang, and it has challenged our understanding of the universe. So what does Brian Cox have to say on this topic? Let's find out. Brian Cox clears up a common misconception about the Big Bang. He believes that the Big Bang occurred everywhere, so the universe isn't expanding into something else. We often think of it as a specific point, but Cox explains that there was no central explosion point because the Big Bang happened everywhere. The explanation is simple. The universe didn't suddenly begin and then expand into empty space. The Big Bang and the expansion of space are the same thing. So, we're essentially in the middle of the consequences of the Big Bang. We, along with countless stars, planets, and cosmic phenomena, originated from it. Viewing the beginning and expansion this way changes our concept of the start, space, and time. Cosmology's wonder and mystery are all around us, and we're no longer just observers but an integral part of it. This perspective also makes it clear how challenging it is to look back because everything has changed over time. Nevertheless, scientists say that structures today are similar to what they were during or immediately after the Big Bang. It's somewhat like inflating a balloon. Even as it changes, you can trace its structures back to the beginning. The mystery of time in cosmology has an intriguing effect. When we look at the sky, we're looking into the past, seeing the remnants of that massive explosion. Every point in the universe today was part of that original moment. The inflationary theory explains how the universe could expand rapidly and possibly how it might end. Currently, researchers believe that the expansion won't last forever. The universe might eventually freeze, rupture, or contract like a rubber band, and possibly be reborn. The challenge is that there's no concrete evidence to support these assumptions. Neither the Big Bang nor the expansion has been definitively proven. Everything is based on observations and model calculations trying to trace present phenomena back to a starting point. The universe is based on relationships and the dependence of certain quantities on each other. We can calculate these relationships successfully, but it's not as straightforward as putting them into a linear timeline. Einstein's theory of general relativity, formulated in 1915, describes physical aspects of three-dimensional space and time. It has been supported by various proofs, including the expansion of the universe discovered by Hubble in 1929 and effects of gravity, gravitational lensing, space-time curvature, and time dilation. Even Albert Einstein couldn't quite pin down what time truly is. He had a hunch that time might be just a trick of human perception. St. Augustine, also known as Augustine of Hippo, was an early Christian thinker who lived from 354 to 430 AD. He dived into the nature of time and found it challenging to define, even though we all understand it. He remarked, "What then is time? If no one asks me about it, I know it. But if I want to explain it to someone who asks, I do not know." Augustine argued that time doesn't exist independently. It's tied to how humans perceive it. He distinguished between the past, present, and future, pointing out that the past and future, in a sense, aren't real. The past is gone, and the future hasn't happened yet. Only the present, which he saw as fleeting and elusive, can be genuinely real. But consider this. When light that's been traveling for 13.5 billion years in the universe reaches the mirrors of our telescopes, it's as if it was emitted from one place and now arrives at another. However, we're right in the midst of the ongoing Big Bang expansion, so you realize that this light didn't travel through space from one point to another. Instead, the effect of space and time comes from the expansion itself. Now, what existed before our perception of time's beginning? Even if time is something we perceive, it's still real to us. Time spans start, pass by, and come to an end. We have the concept of a beginning and an end. For Augustine, only God existed outside of time as an eternal being who created time and space itself. Albert Einstein looked at time from a physical standpoint. His special theory of relativity introduced the idea that time isn't consistent throughout the universe. Think of it like this. Imagine the balloon again, and you can grasp that time may pass faster at one end than at the widest part. Einstein didn't see time as an absolute. It was connected to other things, particularly speed and gravity. This leads to an intriguing question. Can we, as part of the balloon, uncover what the beginning was and whether something existed before the balloon appeared? According to Brian Cox's explanations, this is a possibility. The Big Bang serves as the inception of time. The Big Bang theory presents the universe's start as a singularity concept, a state with no time, space, or matter. But here's the kicker. Where did this singularity come from? And did it exist within time? These are challenging questions, not only for scientists, but especially for physicists. Today, machines are helping us fathom these intricate processes. Simulation programs can ingest massive amounts of data and compute various scenarios in line with known values from physics and mathematics. According to these calculations, there was nothing before. But quantum physics teaches us that nothingness can't exist. It's a collection of particles continually appearing from a field, flickering, neutralizing each other, and vanishing again. None of these particles takes a solid form. This fluctuation, as measured by our physical standards, is nothing, zero, and yet it's something. Pure potential, albeit unformed. Brian Cox integrates this insight with other cosmological models and suggests that before the Big Bang, there was no matter, but there was an energy ocean, almost still but gently undulating. Even though this place lacked structures, the energy influenced space, ultimately causing its expansion. In the beginning, the expansion wasn't the gradual and sometimes sluggish evolution of the cosmos we observe today, but an incredibly violent moment with forces beyond our imagination. If we take the metaphorical concept of an energy sea and combine it with the notion of singularity, instead of a singular concentration point, we have a vast array of points. The Big Bang, as per Brian Cox's theory, began from just one of these particles due to a disturbance in the gentle energetic waves. What we observe today started with colossal forces, initially resulting in intense heat. As the universe expanded, it slowed down and cooled. This cooling and slowing allowed elementary forces like electromagnetism, radiation, and gravity to give birth to particles. These particles began to interact and build structures, which ultimately led to things like human DNA, planets, plants, and of course, stars. Einstein had doubts about what came before the Big Bang. He considered discussions about what existed before this event to be futile. In his view, there might have been nothing comprehensible to humans before this occurrence. However, this perspective challenges the fundamental idea of cause and effect relationships in physics. Every effect should have a cause or reason. Hence, Einstein's notion that nothing existed before the cosmic singularity appears inadequate. Brian Cox's concept of quantum fluctuation has now become an accepted extension of standard cosmology. Although we understand and can explain these effects, quantum mechanics opens a realm that's difficult to measure and describe. Werner Heisenberg termed this realm the fuzziness. As of now, we can't decode the blueprint of matter in its current state because our measurement techniques fall short at this boundary. The situation is similar when considering what existed before the Big Bang. Brian Cox's vision of a particle carpet doesn't include measurable quantities. Quantum physics has uncovered another intriguing phenomenon that might offer some insight. The universe's fundamental building block is information, and it can neither be created nor destroyed. This means that the basic attributes of our universe, such as spreading and changing information, must have been present in the singularity or the neutral energy carpet from which everything emerged. Information isn't neutral, and it's not nothing. Therefore, we must now assume that the information that formed our universe is eternal. The intriguing idea of a universe emerging from eternal information challenges our conventional grasp of time and existence. It proposes that the basic building blocks of our cosmos were encoded within this vast sea of energy, patiently waiting for the right circumstances to unlock their potential. Although quantum physics and cosmology have given us these captivating insights, the mysteries of existence keep revealing themselves. The question of what came before the Big Bang remains a puzzling puzzle, pushing the boundaries of our understanding. It serves as a reminder that the universe is a domain of endless marvels and discovery. So what are your thoughts on this? Write them in the comments below.